think some geometry plays very important role, the triangle, the circle. So these ideas are very important. You be careful because now everyone knows torque. I think there's no problem with the idea of torque here. No? So what will trouble everyone is the geometry. So you be alert with the geometry involved with the numerical. I think will be on safer side. What are the forces that are going to act? It's saying it's in equilibrium. So the tension T, the tension in the rope, and it is find the minimum coefficient of friction between the incline. This one also find the mass of the block. I don't know mass of the block. I'll call m naught. We don't know this. It has to be determined. The tension T, it will be in this direction. Then the weight mg sine theta and mg cos theta. What should be the direction of friction? See again for equilibrium, it is an equilibrium misspelling. Torque by tension about O will be anti-clockwise. Will be like this. So torque by the friction should be clockwise. So therefore the friction must act in this direction. Because torque due to tension will be clockwise. This is R bar, this is F. It will be clockwise. Torque due to tension will be anti-clockwise. So therefore the friction, I should assume like this. Friction, see like you should check all the things. Then friction downward. So friction downward, okay, no problem. mg sine theta and the friction will be balanced by component of tension. Okay, fine. But if the friction is downward in this direction like this, then torque due to tension as well as friction both are in anti-clockwise. No, net torque is non-zero, but it's saying equilibrium. So therefore, I should assume the friction in this way. So not only just torque, you should also take help of the force as well as the torque, and it should satisfy the condition of equilibrium. See, next week what I do, the same problem, I will just decrease the value of m naught what we calculated and I'll ask you the problem. Then they'll start, this will start moving and rotating. This will moving up or down. This one. So once you are familiar with how the forces are acting, is writing equations of motion is very easy. So it's asking the quotient of friction here. Let's come for the net torque on the cylinder about 0.2. Should be 0. Then wall will set up torque F into R plus T into R. But the tension acting, I think tension will act tangentially to the cylinder. No? The tension will act tangential to cylinder. So T into R will be this one. So this will be R. This is T. What is the angle? 90 degrees. So the very first equation what I'm getting is F equal to T. Then tension T equal to m naught G. This is another equation on the block. This is the torque. So therefore T equal to mg. This is the equation 2. For along the incline on the cylinder. Along incline on the cylinder. Mg sine theta minus F. Any other forces along the incline. Component of tension. T cos theta should be equal to 0. Call equation 3. Perpendicular to incline. Perpendicular to incline. What are the forces? Component of tension will come. I'll just show it here. Try to see this. Shall I resolve this tension? And what can be this angle? Theta. So T cos theta, T sin theta. So perpendicular to incline, the normal contact, I'm showing it here. I don't have a place there. Then N minus mg cos theta minus T sin theta. So what we have to do here? You have to solve for f, solve this equation 1, 2, 3, and get expression for small f. And then in the equation 4, solve for n. Then for equilibrium, what should be the f? The friction should be greater than mu n or should be less than mu n? For equilibrium, what is the basic condition? F should be less than mu n, no? From here, what happen? I'll get a condition. But we don't know F, how to calculate. It's a static friction. I think solving these equations. I think substitute 1 in 3. T is equal to F will come. So put 1 in 3. Solving for F. I'll end up with the equation mg sine theta 1 plus cos theta. This is m naught. Just a small change again. For block here, the tension is this m naught is unknown, no? So T equal to m naught g. And then how to eliminate tension? So again, I'll substitute back f there. I'll get expression for T. Sorry, I need expression for n. For that, I need expression for T here. Solving this, n will be mg 1 plus cos theta, or n will become equal to mg. Huh? So substitute all this, mg sine theta 1 plus cos theta should be less than mu mg. I'll get expression for mu. Then how to calculate that m naught is needed, no? So you know f, substitute here, then T is equal to f. This, then if you know tension, then you can bring the m naught. So I'll write down m naught value. You do calculation later on, it just only, these are our answers. Solving this, so mu should be greater than, or minimum value is asking. So what should be the minimum value of mu? Should be sine theta by 1 plus cos theta. If the value of mu is greater than this, equilibrium is possible. Less than this, equilibrium is not possible. That's why the minimum word is being brought here.